So far we've looked at how to use ease to obtain a single solution to a set of equations. Often it's more interesting to run a parametric study where you vary the value of one independent variable and you study the effect on other predicted dependent variables. So let's illustrate this with the ease solution to exercise 2, question 1 of the ease on-ramp course. So this is the solution to the problem shown here, in which a pulley is being used to lift a mass. And the problem asks for the acceleration of the mass if the force applied to the pulley is 120 Newton. And it requires the solution to this set of equations. And so for this particular set of inputs, the acceleration is shown here in the solutions window. So the great thing about using a computer to solve a problem is that I'm not limited to one solution for one value of the inputs, and ease makes it particularly easy to examine how the solution responds to changes in the input variables. So in this case, I might want to know how the pulley radius or the pulley thickness or its density affects the acceleration of the mass. And this kind of parametric study is really the key to understanding how your problem behaves and understanding your solution. So if I want to parametrically vary one variable, for example, in this case maybe the pulley radius, and study its effect on another variable like acceleration, then what I need to do in ease is create what's called a parametric table. And to do this, I would select a new parametric table from the tables menu, and that will bring up the new parametric table dialog that's shown here. The window on the left side of this dialog provides a list of all the variables that are currently included in your solution. From this list, then, you can select variables that you're interested in the parametric study. So you would certainly select the independent and the dependent variables of interest. So in this case, I would select the variables r sub p and a, and I do this by clicking on them, and then I hit the add button, and that will add these variables to the window on the right side. The list on the right side then is all the variables that will be included in the parametric table. And I can include any other variable that I want to from this list on the left. In this case, I'm just going to stick to those two. And when I select OK, I'll create a parametric table. By default, there's 10 runs in the table, but you can add or remove runs if you'd like. You do that by selecting the Insert Delete Runs command from the table menu, or by just right-clicking on any run in the table and then selecting Insert Runs or Delete Runs. You'll notice that there's a column in the table for each of the variables that you selected. So you can add more columns at any time if you'd like. You just select Insert Delete Variables from the tables menu to add columns or get rid of them. Or again, if you right-click on any column, and then you can select Insert Column or Delete Column. To carry out a parametric study in which the pulley radius is changed, it's necessary to fill in the column here for the variable r sub p with the values of the radius that are of interest. And this process can be done manually, one run at a time, but that's pretty tedious. So more typically, you will right-click on the column of interest and then select Alter Values, which will bring up this Alter Values dialog. And you can select the rows to be filled in. So in this case, I'm going to fill them all in, so 1 to 10. And then also the pattern that you want to use to fill in the values. So here, the values of r sub p will go from 0.02 meters in row 1 to 0.2 meters in row 10 using equally spaced intervals. Note that because r sub p has alternate units assigned, so in this case, not only is its value of the units meters, but I have assigned alternate units inches, and because of that I can also specify its value in the table in inches instead of meters. So I could go from sort of 2 inches to 20 inches if I wanted to. Other options for entering values can also be specified, and you do that by just click on the drop down menu under first value, and so you can see some other options here. One that's particularly useful if you're going to eventually make a logarithmic scaled plot would be the last log, because that will logarithmically space the values in the table. If you are using the professional version of ease, the value entered for last row here can actually be set to a value greater than the current number of rows in the parametric table, and then ease will just extend the number of rows in the table to this new value. So here, if I enter, for example, 15, you'll see that it just grows the table to 15 runs. And the other nice thing about the professional version is that you can use actually ease variables instead of numerical values to provide the first value or the last value or the increment value. So for example, I can go back to the equations window, and I can define a variable r sub p min and set it to 0.02 meters, and I can just use that value then to set the minimum value of the radius, as I've done here. So when you're ready to solve the table, you run it or solve it by selecting the solve table command from the calculate menu, or by using the F3 shortcut button, which I tend to do a lot. When you select solve table, you'll bring up this solve table dialog, which is shown here. When you press the OK button, that prompts ease to solve the runs in the table. The dialog is initially set so that ease will start with 1 and end with the last run, but these can be changed as you wish if you want to solve just a subset of the runs. So what ease will do then is we'll begin with the first run that's specified here, and it will look in the table to see which columns in that run have specified values. And then it will specify the values of those variables in the equations window, solve the resulting system of equations, and use that solution to fill in all of the remaining columns in the table. So therefore, when I press OK, ease is going to go to run 1 of this parametric table, and it's going to find that the value of r sub p is set to a value, in this case 0.02 meters, and you can literally imagine ease placing in the equations window the equation r sub p equals 0.02 meters. And of course, the way things are set up now, this is going to present a problem because there's already an equation in the equations window that's setting r sub p to a different value. And of course, one variable can't have multiple values, and you've over-constrained the equation set, and you're going to get an error. And so what we need to do is first comment out the equation in the equations window that specifies r sub p, so that we can then specify r sub p in the table itself, right? And the easiest way to do this temporarily is just to highlight the statement, the equation here, right click, and then select comment, and you'll see that that temporarily removes that equation from the equation set. And now we can solve the table without any issues, and you'll see here that for every value of pulley radius that I've set, I have a corresponding value of the acceleration. So there's all kinds of other things you can do with these parametric tables. One thing that you'll often want to do is solve only a portion of the table, and that's pretty easily accomplished by changing the first and the last run numbers in the solve table dialog. If you have the professional version of ease, actually the start and stop run values can also be set to variables. So for example, I can add lines in the equations window specifying a start row of 3 and an end row of 7, and then I will open the table. First I'm just going to clear the solutions I have, so I'll just select clear values from the alter values dialog. It clears the column, and now I'll solve the table again, so F3, and this time if I click on the arrow next to first run number, I'll actually change it to first run variable and then enter the variable I want to use, so start row, and I can do the same thing for the last row, so I'll change last run number to last run variable and enter end row, and if I hit OK, you'll see that only runs 3 through 7 have been filled in. Okay, so really, in order to examine the results of a parametric study, the best way to do that is with a plot. So I would encourage you to watch the next video, which is just an introduction to how you plot data that are contained in tables in ease.